So, good afternoon, everyone. So, I am here today to tackle about the most important topic, which is the geology. So, first, let's find out the definition about what is geology. So, geology is made up of two words. So, geo means earth, and logos means fish and study. So, geology is the study of Earth, including the materials that it is made of, the physical and the chemical changes that take place on its surface, and its interior and the history of the planet and its life form. So, geology is broadly divided into the physical geology and history geology. So, physical geology is concerned with the materials and processes which compose and operate on the surface or within the earth. And the historical geology is concerned with the origin and evolution of Earth's continents, oceans, atmospheres, and life. So, geology has also branches. So, the first one is physical geology. Physical geology is concerned with the physical processes and physical properties of the earth and its surrounding space environment and the use of quantitative methods of their analysis. So, physical geology is consists the natural processes which bring about the changes upon the earth's surface. So the next one is the petrology. So petrology is the studies the origin of composition, distributions, and structure of rocks. So meaning to say it is actually related to the study of the rocks. So the next one is the mineralogy. Mineralogy is the study of minerals, its composition and properties. So it is related from the minerals. So that is what we study in the composition and properties of minerals, which is the mineralogy. So the next one is the structural geology or tectonic. So the study of the three-dimensional distribution of rocks units with respect to their deformational history. So the structure of rocks and so the next one is the stratigraphy. So, stratigraphy studies rock layers, which is strata, and the layering, which is the stratification. It is primarily used in the study of sedimentary and layered volcanic rocks. And then the paleontology. It is simply the study of the ancient life, the study of the fossils to determine organisms, evolution and interaction, which is other and their environments, their paleoecology. So, it is simply base studies of fossils. The next one is the crystallography. It is the experimental science of determining the arrangement of atoms in the crystalline solid. So, it is actually learning about the arrangement of atoms in crystals of said, which is the crystalline solid. And then the next one is the mining geology, an applied science which combines the principle of economic, geology, and mining engineering to the development of defined mineral resource. So, mining geology, geology engineering, and hydrology it is. So these are actually the application of other branches. So if you are planning to become a geologist, then it is important to know the scope of the geology application of how does the geology important to the human and the mankind. Okay, so geology engineering is the application of scientific methods and engineering principles to acquisition, interpretation, and use of knowledge of materials of the Earth's crust and Earth materials for the solution of engineering problems and the design of engineering works. And then the last one is the hydrology. So the study of the movement, distribution, and equality of water on Earth and other planets, including the hydrologic cycle, water resources, and environmental watershed sustainability. Okay, so now geology in our lives. So actually, geology, we've been using it in everyday life. So geology is relevant to everyone's day-to-day life. So metals and energy sources such as coal and petroleum are geologic products that build and power modern society. So coal and petroleum are the product of geology. Water is a precious natural resource is used in an industry, agriculture, and domestic purpose is also a geologic product. Natural hazards like tsunamis, landslide, earthquakes, and volcanic eruption are also related to geology. So these are all related to geology. And the water natural is the source or also the product of geology. So the processes acting on Earth. So the Earth is the dynamic system that it is undergoes constant changes with time both internally on its surface. So internal processes, which is the process that originated deep within the Earth, and termed as internal processes. These are the driving force that raise mountains, cause earthquakes, and produce volcanic eruptions. So mo makakause sa earthquake and makakause siya sa volcanic eruption. Mo gitawag nga internal processes. So then, the next one is the surface processes. So, surface processes are all those processes which take place on the Earth's surface and result in the sculpting the Earth's surface. Most of the surface processes are driven by water through wind, ice, and gravity are also play an important role. Okay, so what does a geology do? So now let's find out what does do a geology. So geology works to understand the history of our planet. The better they can understand Earth's history, the better they can foresee how events and processes of the past might influence the future. And then geologists study Earth processes. Many processes such as the landslide, earthquakes, floods, and the volcanic eruption can be hazardous to people. Geologists work to understand these processes well enough and to avoid building important structures where might be damage. If geologists can prepare maps of areas that have flooded in the past, they can prepare maps of areas that might be flooded in the future. So meaning to say, if makapreparar sila sang mapa sa karon, then makapreparar pud sila sa mga sang mapa nga makahibaw sila asa dapit ang dangerous nga asa dapit nga area ang flooded, so they might know where it can be in the future. So these maps can be used to guide the development of communities and determine where flood protection, flood insurance is needed. And then geology study earth materials, so they are also study the earth materials. People use earth materials every day. They use oil that is produced from wells, metals that is produced from mines, and water that has been drawn from the streams or from the underground. Geologists also conduct the studies that locate rocks and that contain important metals, plan the mines that are produced them, and then the methods used to remove the metals from the rocks, and then they do similar work to locate and produce oil, natural gas, and groundwater. So the kanang daghan jud di sila gistudyuhan, dili lang kay usa ka butang. Okay, then geologists is also study the earth history. So today we are concerned about the climate change. Many geologists are working to learn about the past climates of Earth and how they have how they have changed across time. So this historical geology news information valuable to understand how our current climate is changing and what the result might be. So gistudyuhan po di ay nila ang pagbag-o sa climate karon o sa mga umaabot pa o kung unsay marisulta pa sa mga umaabot. Okay? And then, now the geosphere. So, the area near the surface of the Earth can be divided into 4 interconnected, which we call the geosphere. So, the atmosphere, the hydrosphere, the lithosphere, and the biosphere. So, the Earth, which is the atmosphere, and then the hydrosphere, which is the water, and then the land, which is the lithosphere, and then the life, which is we call the biosphere. Okay, as you can see the picture shown below. Okay, so the next one is the atmosphere. So, the atmosphere is the body of the Earth which surrounds our planet. So, mao na siya nakapalibot sa tong planeta. Most of our atmosphere is located close to the Earth's surface where it is most dense. The atmosphere not only provides the air that we breathe but also acts to protect us from the sun's intense heat and dangerous ultraviolet radiation. So, ang sun di ay dili lang kay naghatag siya para maka-break kita, kundi nagprotekta po di siya sa kainit sa adlaw o sa radiation. And then, the energy exchanges that continually occur between the atmosphere and the surface and between the atmosphere, the space produces the effects we call weather and climate. And then the air of our planet is 79% nitrogen and just under 21% is the oxygen. The small amount remaining is composed of carbon dioxide and other gases. So meaning to say, it's only 3% for the carbon dioxide and for the other gases. So let's proceed for the next slide. Okay, then hydrosphere. So the hydrosphere is composed of all of the water on or near the earth. This includes the oceans, rivers, lakes, and even the moisture in the earth. And then 97% of the earth water is in the ocean. So, ang 97% di ay nga water is naa di siya sa oceans. Then the remaining 3% is fresh water. 3/4 of the fresh water is solid and exists in ice sheets. So as you can see the bar graph, so this is the distribution of Earth's water. So from the Salins water ocean, so they got a 97% from the Earth's water, and for the fresh water is only 3%. And then let's see the middle bar. So the groundwater is the 30.1%, and the ice cap and the glacier is 68.7% fresh water, and then the other is only 0.9%. And then for the swamp is 11%, the lakes is the 87%, which is the fresh surface water liquid. And then the rivers is only 2%. And then now let's go to the next slide. So the lithosphere. So beneath the atmosphere and the ocean is the solid earth or lithosphere. The lithosphere is the solid rocky crust covering entire the planet. This crust is inorganic and it composed of minerals. So as you can see in the picture, which is the lithosphere, nga mura siya kanang rocky crust siya nga nag-cover siya sa entire planet. So muna siyang gitawag nga lithosphere, nga mura siya crust. Okay, so nag-compose ni siya og minerals. Okay, so now let's go to the biosphere. So the biosphere is composed of all living organisms, which is the plants, animals, and one-celled organisms are all part of the biosphere. So most of the planet's life found from 3 meters below to the ground to 30 meters above it, and it top 200 meters of the ocean as say. So biosphere is composed of all living things, or all living organisms. Sorry. So muna siyang fish, or the animals, the plants, and the one-celled organism. Okay. So now let's proceed to the uniformitarianism and the catastrophism. So James Newton, a Scottish gentleman in 18th century, gave concept of uniformitarianism. According to the principle of uniformitarianism, geological changes take place over a long period of time. So Newton summarized the geological process operating today also operated in the past. Therefore, scientists can explain events that occurred in the past by observing changes that are occurring today. So sometimes this whole idea is also known. The present is the key to the past. So I also agree with this quote. Okay, kay ato man jud nang kumbaga atong i-research ang mga miagi nga mga panghitabo nga aron masayod kita og unsa. Okay? So as you can see the picture shown below, so this is the uniformitarianism. So the formation of river valleys due to the action of running water or the movement of the continents are example of the very slow and the gradual changes. So, hinay ang iyang pagbago. As you can see in the picture, right? Okay. So, uniform materialism and catastrophe. So, William Whewell, another early geologist, agreed that the Earth is very old. So, but he argued that geologic change was sometimes rapid. He also wrote the geologic past may have consisted of epoch catastrophic action interposed between periods of comparative tranquility. This phenomenon where Earth was subjected to rapid geological change as a result of certain catastrophe came to be known as catastrophism. So, catastrophe which is called to be known as catastrophism. So, mao na siya ang gitawag. Okay, then, so as you can see in the picture shown below, so mao na siya ang catastrophism, which is the volcanic eruption, the flooded area, and the earthquake. Okay, so today geologists know that both Newton's uniform materialism and Whewell's catastrophism are both correct. So those over the great expanses of geologic time slow, uniform processes are significant but improbable. Catastrophic events radically modify the path of slow change. So, mao siya ang hinay nga pagbago. Okay, so now let's find out the rock cycle. So, rock is the most common and abundant material on Earth. Okay, so a rock consists of smaller crystals and grains called minerals. So, minerals are the chemical compounds or sometimes single elements, each with its own composition and physical properties. The grains or the crystals may be microscopically small or easily seen with the unaided eye. Okay, so the nature and the appearance of a rock is strongly influenced by the minerals that compose it. So, nagcompose siya og minerals ang rocks. Okay, so a rock's feature, the size, the shape, and the arrangement of its constituent minerals also has a significant effect of its appearance. So, na siya epekto sa matag-usa niya ka-appearance. A rock mineral composition and texture in turn are a reflection of the geologic processes that created it. Okay, so geologists divide rocks into three major group, which is the igneous rock, the sedimentary, and the metamorphic. Okay, so now let's find out the igneous rock. So, magma is the molten material which is formed when the pressure and temperature condition are high enough to melt the rock. So, magsugod diay siya sa magma. Kanang mahilis. Then, after the magma is formed in the interior of the earth and then gradually migrates upwards to the earth crush. And then, when it reaches to the surface, it cools and solidifies by the process of crystallization. The rocks formed as a result are known as igneous rocks. So, gikan sa magma kanang mahilis, hantod kung mabugnaw na siya, mahimo na siya nga kanang murag crystal, mao na siya ang gitawag nga igneous rock. Okay. So now let's find out the sedimentary rocks. So these igneous rocks, when exposed to the atmosphere, undergo weathering where they disintegrate into smaller particles. These particles, known as sediments, are transported by the agents of the erosion such as water, wind, and ice. So, finally, these sediments are deposited. These sediments are then converted to the rocks by the processes of lithification. So, the resulting rocks is known as the sedimentary rocks. So, the sedimentary rocks. Okay, so now let's find out the metamorphic rocks. So, if the resulting sedimentary rocks is the buried depth within the earth and involved in the dynamic and a mass of magma, it will be subjected to the great pressure and or intense heat. So the sedimentary rock will react to the changing environment and turn into the third rock type, which is the metamorphic rock. So when the metamorphic rock is subjected to the additional temperature, additional pressure changes or to still higher temperature, it will melt, creating so ang kanadiang metamorphic rocks kung mahimo kung ma-melt din na siya or mahilis, mahimo na siya nga magma. So, which will be eventually crystallized, which is into mahimo siya nga igneous rocks, then starting the cycle all over again. So, balik-balik ang iyang cycle. So, gikan sa primero hantod sa kinalasan, maura gyapon ang iyang cycle. Okay, so next, as you can see, the rack cycle. So, the rack cycle is the fundamental concept of geology that describes the dynamic transition through geologic time among the three rocks types. So, each type of rocks is altered or destroyed when it's forced out to equilibrium conditions. Okay, so now let's proceed for the formation of the solar system. So, Earth was not ground and beginning. The universe began without us some 10 billion years than Earth. So, the universe started out with only two elements, hydrogen and helium gas. So, they also formed stars that born these elements in nuclear fusion reaction. And then, the generation of stars were born in gas clouds and then died in explosive novas. So, long ago, some 5 million years ago, so a supernova exploded, pushing a lot of its heavy element wreckage into a nearby cloud of hydrogen gas interstellar dust. Okay, so now let's proceed to the next slide, so which is the formation of the solar system. So the mixture grew hot, compressed, and under its own gravity and its center, a new star began to form. So which is, as you can see in the picture, so kanang naa sa tunga mo na siya ang nag-form nga bag-o nga star. Then around it swirled a dust of the same material which grew white hot from the great compressive forces. Kanang white ka naa sa tunga, as you can see in the picture. And then that new star became our sun, and the glowing dust gave rise to Earth and its sister planets. Okay, so now let's take a look at the formation of the solar system. Okay, so the Mercury, Venus, Earth, Mars, Jupiter, and the Saturn, Uranus, Neptune. So these are the what they call planets. So, and then there are also dwarf planets, which is the Pluto, and the Hamuya, and the Mechanic, and the Eris, and the Ceres. So mo na siyang itawag nga the dwarf planets. Okay, so now, so the planets of the solar system can be divided into groups depending on their proximity to the sun and their density. So the terrestrial planets are the four closest to the sun, are all similar to the Earth in density. Okay, they include Mercury, Venus, Earth, and Mars. So all of four terrestrial planets are small, rocky, and dense, which is the 3 grams centimeter or more. So kaning Mercury, Venus, and Mars, mo ni siya ang duol sa Earth. Then puparihara sila og density. Okay, so now let's proceed to the next slide. So the Jovian planets are those farther from the sun than Mars. So they include Jupiter, Saturn, Uranus, and the Neptune. So they are much larger than the Earth, but their densities are very low. So meaning to say, mas dako pa sila sa what we call sa Earth, pero ang density nila kay ubos. So they are made up of light elements, most hydrogen and helium, and hence their densities are low. So ubos ang ilang densities kay sa Earth, pero mas dako pa sila kuno. Okay. So, the formation of the Earth. Okay, so the Earth is approximately 4.6 billion years old. So, grabe, pinakadugdugay na juday kayo. And it is believed that it was formed by a creation of small particles. So, nagsugod ra siya sa kinagamyan nga particles. Then, the Earth has a layered structure. The center is a dense, hot core composed mainly of iron and nickel. And then, A thick mantle composed mainly of solid rock. So nagcompose siya og solid rock, then surrounds the core and the contains 80% of the Earth's volume. So the crust is a thin surface also composed of rock. Okay. So as you can see in the picture shown below, so the crust, which is the continental or the oceanic, mo na nakapalibot sa Earth. And then the next one is the mantle. Then the core, which is the outer and the inner core. Okay. So the crust Earth is relatively thin. Rocky outer skin is of two different types, which is the continental crust and the oceanic crust. So the oceanic crust is roughly 7 kilometers thick and composed of the dark igneous rock basalt. And then the continental crust has an average thickness of about 35 kilometers, and it composed mainly of light-colored igneous rock called granite. So, lahi-lahi din ang iyang kuan. Kaya ang sa oceanic crust is only 7 kilometers thick only, then the continental crust has an average thickness of about 35 kilometers, and it is also composed mainly of light-colored igneous rock, which is called the granite. Okay, then the continental rocks have an average density of about 2.7 grams centimeter and are older age up to 4 billion years old. Grabe. Dugaya na jud ay, okay. So the rocks of the oceanic crust have an average density of 3.0 grams centimeter, are younger in age 180 million or less. Okay. Okay, the mantle. So now let's proceed for the mantle. Okay. For more than 82% of Earth's volume is contained in the mantle, a solid rocky shell that extends to the depth or nearly 2,900 kilometers. So the boundary between the crust and the mantle represent a significant change in the chemical composition. And then the dominant rock type of the uppermost mantle is peridotite, which is richer in the metals magnesium. So, and then the iron, then the minerals found in either the continental or the oceanic crust. Okay, so now let's find out the core. Okay, so the core is the composition of the core is thought to be an iron nickel, which is the alloy. When the minor amounts of oxygen, silicon, and sulfur elements that readily form compounds with iron. At the extreme pressure found in the core, this iron-rich material has an average density of nearly 11 grams or centimeter. Okay, the core is divided into the two the regions that exhibit very different mechanical strength. So the outer core is a liquid layer, which is the 2,270 kilometers thick. It is the movement of the metallic iron within this zone, and then that generates Earth magnetic field. And then the inner core is a solid sphere having a radius of 1,216 kilometers. Despite its higher temperature, the iron in the inner core is solid due to the immense pressure that exists in the center of the planet. Okay, so now let's find out the geologic time. So how long is the 4.6 billion years? If you were to begin accounting of the rate of one number per seconds and the continued 24 hours a day, which is the 7 days per a week, and never stop, it would be take about 2 lifetimes, which is the 150 years, to reach 4.6 billion. Okay, so the Earth is estimated to be 4.6 billion years old. And then the geologic time differs from the human perspective of time. And Earth goes through cycles of much longer duration than the human perspective of time. Then the geologic time scale is the calendar that geologists use to date past events in Earth history. So, muna siya ang gigamit sa kanang geologists, ang kanang time scale calendar. Okay, the geologic time scale is divided into the eons, the eras, the periods, and the epochs. And It is identified primarily by the types of life that existed and the virus of times. Then, the two earliest ions and the Hayden and the Archean cover the first 2.5 million years of Earth history. Then the life originated during the Archean time, and with the passage of time, the life form evolved. Evolution was very gradual. Until the last 5 million years, where many new species evolved, which were more complex than their ancestors. So that would be all, and thank you.